So we are discussing the next topic in phase equilibria, that is freezing mixtures. Freezing mixtures we are used for attaining low temperature for different purposes, and usually freezing mixture is a mixture of salt and ice, and we are used to get it for attaining lower temperatures, used to for attaining lower temperature for different chemical reactions or preserving something or something like that. And salt water system always form a salt ice system. You always form a freezing mixture. When salt is added to ice at 0 degrees centigrade, salt dissolves and the system become in non-equilibrium. Ice two processes take place during this addition. After this addition, that is, ice will melt. At the same time, the salt continue to dissolve in the water formed. So there are two processes: melting of ice and dissolution of salt taking place simultaneously, and both these processes are endothermic processes. So temperature of the system decreases due to these two endothermic processes, and this temperature decrease continues till eutectic temperature of the salt water system is reached. In the last session, we have discussed the salt water system of potassium iodide and ice, and we know that this curve will follow the eutectic curve and after reaching eutectic temperature, this temperature decreases till the eutectic temperature is reached. And it after attaining the eutectic point, it will remain at this temperature until ice will melt or all salt dissolves. And this you will do in your practical classes. For attaining low temperature for diazotization reaction, we will use this ice and salt, common salt, for attaining low temperature for diazotization reaction. And then ice melt, so it will remain in eutectic point until all ice melt or all salt dissolves. What are the conditions for a good freezing mixture? So freezing mixtures are used for getting low temperature, for attaining low temperature in systems for various purposes, and good freezing mixture will have a low eutectic temperature. Since the temperature falls till eutectic temperature is reached, a good freezing mixture will have a low eutectic temperature, and it will have a high heat of solution of salt. Then only this we will get low temperature, high heat of solution of salt, and low cost of salt. That also an important factor, since potassium iodide is very expensive, so we cannot use it economically for making a freezing mixture. But sodium chloride is very cheap, so we can use it for making for the purpose of preparing freezing mixture. These are the eutectic temperatures of different freezing mixtures. For example, sodium chloride ice system, we will have a eutectic temperature of -22 degrees centigrade. Ammonium chloride ice system, eutectic temperature -16 degrees centigrade, and calcium chloride ice system, we will have -55 degrees centigrade. And there are freezing mixtures other than ice salt system. And an example for such a freezing mixture is acetone dry ice freezing mixture. Solid carbon dioxide, dry ice means solid carbon dioxide, directly sublimes at atmospheric temperature, and the heat required is taken from acetone. So temperature falls up to melting point of acetone, that is -90 degrees centigrade, but till -60 degrees centigrade we get that lower temperature up to -60 degrees centigrade using acetone dry ice freezing mixture. The importance of freezing mixtures is that high energy or reaching a lower temperature is a very expensive process. If you want to reduce temperature up to -4 degrees centigrade itself, it will be a very expensive process. But using this freezing mixtures, we can attain this low temperature, not much expensive. No, and this process is not as expensive as other methods to attain low temperature. This is the importance of freezing mixtures. Now, the thermal analysis, that is construction of cooling curves. Cooling curve എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ എന്താണ്? Construction of cooling curves ആണ് അടുത്തത്. Thermal analysis is the study of cooling rates of various composition of a system. Cooling curve എന്ന് പറഞ്ഞാൽ അത്രേ ഉള്ളൂ. Just this cooling rates at various composition during solidification by means of temperature time curves. This cooling curves are plotted. Temperature time curves are used to plot the cooling curves. Various transformations are indicated by breaks or discontinuities in these curves. There are various transformations indicated by the breaks. ഇനി നമുക്ക് ആദ്യത്തെ കേസ് കൺസിഡർ ചെയ്യാം. If there is only one pure component and let B be the freezing point of that pure component. Pure component മാത്രമേ ഉള്ളൂ. അതിന്റെ freezing point small b ആണ്. We are taking it as small b. Then if we are starting from point small a, when the freezing point of the substance, freezing temperature of the substance is reached, that is at point b, the solid substance of that pure substance begins to appear. And after that, if we are cooling it, cooling is pure substance, after this we will get a constant temperature, or temperature remains constant until liquid completely gets solidified. Then only the temperature drops. That is shown by this curve. That is, we are starting from point A where there is pure substance, and when the temperature during cooling, as the temperature is reached, as the temperature of solidification or melting or freezing point of the pure substance is reached, then the solid begins to appear. After that, the temperature remains constant for some time, and till the whole solid gets all liquid gets solidified, and then only the temperature drops in cooling curve. And this is the cooling curve of a pure substance. Now, let us consider the cooling curve of a simple eutectic mixture of A and B. Simple eutectic mixture, that is a mixture of A and B. Here also we are starting from a position where small a, which is a liquid, and when as cooling proceeds with time, this follows a line like this, and when the point B, the temperature corresponding to point B is reached, solid A begins to separate. Adile major solid edano that will begins to separate, and then it follows a curve like simple eutectic curve, that is BC. That is then the temperature decreases. We know that the procedures during that is as the temperature decrease, as solid separates, solid A appears, the solution will be more concentrated in solid B, its melting point decreases, and solid A gains, more solid A will be separated, and like that the curve follows the curve, and the system follows the curve BC, and where C which is the eutectic temperature, eutectic point, solid B also begins to separate. Then the temperature remains the same for till all the liquid gets solidified. And after that, the system follows C dash D. B is the freezing point of the mixture. B to C, the cooling curve occurs in a slower rate, and C is the eutectic temperature. And C dash, the temperature remains constant. Then cooling of solid takes place along C dash to D. ഇത് നമ്മളെല്ലാ കൂളിംഗ് കേർവ്സ് പല കോമ്പോസിഷനിൽ എയും ബിയും എടുത്തിട്ട്, ഇതിപ്പോ പ്യുവർ എ ആണ്, മുകളിൽ കാണുന്നത് ഇവിടെ ഇങ്ങനെ കാണുന്നത് പ്യുവർ ബി ആണ്. ബിയും എയുടെയും ഇടയിലുള്ള കോമ്പോസിഷൻസ് ആണ് ഇത്. അതിലെ കൂളിംഗ് കേർവ്സ് വെച്ചാൽ ഇങ്ങനെ ഉണ്ടാവും. അപ്പൊ ഈ കൂളിംഗ് കർവ്സിനെ നമ്മളിങ്ങനെ അതിന്റെ മെൽറ്റിംഗ് പോയിന്റ്സിനെ മാത്രം നമ്മൾ ഒരു കർവിലേക്ക് റെപ്രസെന്റ് ചെയ്യുകയാണെങ്കിൽ we get what is called the simple eutectic curve. ഇതിനെയാണ് നമ്മൾ സിമ്പിൾ, നമ്മൾ വരച്ചിട്ടില്ലേ നേരത്തെ, ആ സിമ്പിൾ യൂട്ടറ്റിക് കർവ് നമുക്ക് ഈ കൂളിംഗ് കർവ്സ് കിട്ടും. ഓർ അതർവൈസ് വി ക്യാൻ സേ ദാറ്റ് this from the cooling curves we have plotted the simple eutectic diagram. This is all about the cooling curves and construction of cooling curves. You must draw these figures in your notebook. Thank you.